Today we're going to look at exponential functions, and we're going to look at graphing them, telling the domain, the range, the y-intercept, and the horizontal asymptote. And we're also going to plot them on a graph. So the form for an exponential function is right here, y equals a times b to the x power. There's a few things that I need to tell you. First of all, the value of a tells you if you are going to have a stretch, oh, misspelled it, stretch, a contraction, or a reflection. So if you have a whole number for the value of a, it's going to be a stretch. If a is a fraction, then you're going to have a contraction. And if a is a negative number, you're going to have a reflection. Sometimes you won't see the value of a, and so in that case it would be a 1, which means you don't have any of these, and you don't have to worry about it. Okay, the value of b in this case is your base. And this tells you whether you're going to have growth or decay. So how do you know that? Well, if b is a whole number, then you're going to have growth. Okay, and the graph of this would start off low, and then it's going to go up like that very quickly. Okay, if b is a fraction, now we're not talking about a contraction in this case. We're talking about something that is greater than 0 but less than 1. So if it's like 1/2 or 1/3, then it's going to be exponential decay. And what that means is it starts off with a large amount and it gets small real fast. So its graph is going to look like this. And you know, when you read a graph, remember you're reading from left to right. So as you're coming from the left, you can see this one's small and then it gets high real fast. You can see this one starts off high and it gets small real fast. And so that's how you know the difference between growth and decay, based on the number, which is your base, the number b. And then you can also, if you have a graph already, you can look at it and say, oh, that's growth, or oh, that's decay. Okay? X is always going to be the exponent. And this is going to be what we plug numbers into to find some points on the graph. So when we look to graph these, you're going to substitute a value in for x, raise b to that power, and work out your equation, get your point, and plot it. Now there's some other information that I need to tell you as far as just looking at your form or looking at your equation, and that's your domain, range, horizontal asymptote, and y-intercept. When we're talking about the domain, we're talking about all the x values. And when we're looking at exponential growth or exponential decay, all of your x values are always going to be included. Nothing is ever going to be left out. In other words, if you look right here, this is always going to go to the left, and this is always going to go to the right. Even though it's going up, it's going at an angle. The same thing here. This is coming down from the left and going to the right. So because of that, every number on the x-axis is going to be included in the domain. So you can put all real numbers. The other thing that you need to know is the range is always going to be above the x-axis. So these two graphs right here are actually above the x-axis. They get really close to it, but they never actually touch it. And so because they never actually touch it, we use an inequality, y is greater than 0. For what we're doing in this lesson, those two things are always going to be the same. The domain's always going to be all real numbers. The range is always going to be y is greater than 0. We also have a horizontal asymptote, and we've worked with these before. Remember your horizontal asymptote in the previous unit dealt with the range. So if you look at what your range is, your horizontal asymptote is going to be exactly like this, except instead of that inequality, we're actually going to put an equals sign. This is that dotted line that you're going to draw on your graph that confines your graph to a certain area. And it will not go past that dotted line. So when I put this on the grid, it's actually going to make sense. You'll see it. The last thing is your y-intercept. And this is where your graph is going to cross the y-axis. Well, if you go back up to your form y equals a times b to the x, your y-intercept is always going to be whatever the value of a is. That is the shortcut version. So whatever a is in the equation, that is also going to be your y-intercept. And you're going to see why in just a second. So I want to write down some examples of exponential growth and decay in equation form so that you can see what I'm talking about with the whole, the base being a whole number or being a fraction. So coming back over here, an example would be if you had something like y is equal to 5 times 2 to the x power. So 2 is the base, not 5. Remember, 5 is a. 2 is the base. The base determines whether it's growth or decay. If 2 is a whole number, then it's going to be exponential growth, okay? And then when you go through to find your domain, range, and horizontal asymptote, remember these three things are pretty constant throughout all of the problems that we're going to be doing here. The only thing that's really going to change is your y-intercept. So if I look at the shortcut, the value of a is 5, so the y-intercept for this particular problem would be 5. And that means it goes up to 5 on the y-axis. Now, an example of an equation that's exponential decay is going to be something like this. Y equals 5 times 1/2 to the x power. So now you see the value of b is a fraction. It falls between 0 and 1. So that means this is going to be decay. It's going to look like this. So now I'm going to actually graph these, and these are two problems that come from your assignment. So we're going to look at the first one right here. And we know it's going to be growth because the value of 2. What you're going to do to actually plot the points, and you don't have to do very many of them because there's only a few good points in this, but you want to make a t-chart. And I forgot to do something very important, and that's to draw the horizontal asymptote. So again, that is the equation y equals 0. That means you go to the y-axis, put a point at 0, and you're going to draw a dotted line through it. So that dotted line is going to actually turn into the x-axis. Okay, so now we're going to look at the equation, and I'm just going to start with 0. 0 is always a very good number to start with. We're going to plug that in for x. So that means I'm going to have 5 times 2 to the 0 power. Well, anything to the 0 power is 1. So that's really 5 times 1, which is 5. And so when I plot that, that's going to be 0, 5, which falls on your y-axis, and therefore there's your y-intercept. Again, that's exactly what you have right there. So the shortcut is just to look at that, and that's going to be your y-intercept. Well, we need another point besides that. So I'm going to choose the point, or the value of 1. So now we're going to put 1 in place of the x. That means 2 is now to the first power. Well, 2 to the first power is just 2. And 5 times 2 is 10. So when I plug in a 1, I'm going to get a 10. And notice, you know, they know this. The people that made this problem know this. And that's why you got a lot of numbers up here on the y-axis. I want to do another value of x, and this time I want to go on the negative side. You want to point on both sides of your graph of the y-axis so you can kind of see how steep the graph is going to be. So I'm actually going to use a -1. So it's going to be 5 times 2 to the -1 power. Well, there's a little shortcut here. If you have a -1 exponent, the base is actually just going to be flipped over. So if your base is a whole number, when you raise it to the -1 power, it's going to flip it and make it look like that. So that's going to be 5 times 1/2. Now I know you don't like to multiply by fractions, but this one is a basic one. That's basically 5 over 2, which becomes 2.5. And you can put that in your calculator. So when we plug in a -1, we get out a 2.5. Now that's also going to be a little bit easier to graph than, let's say, a 1/3 or a 1/5. So, you know, keep it simple, but that is the case. That is what happens. So now I'm going to plot these. 0, 5 falls right here. We have 1, 10 is going to fall right here. And -1, 2.5. So I'm going to go up 2 and then another 1/2. because there's the 0.5. So you can see how the 3 points are kind of lined up, and you're just going to connect them. Remember, this is just a sketch. Extend that up, and then you're going to bring this down toward the horizontal asymptote, but you're not going to touch it. And there's your graph for number 1. Okay? Now I'm going to do number 4. Same kind of problem. We're going to use a T-chart. And again, I'm going to go ahead and draw the horizontal asymptote, which is y is equal to 0. And again, I'm going to start with 0 for the first value of x. So that means I'm going to do 5 times 1/2 to the 0 power. Again, anything to the 0 power is 1. And so 5 times 1 is 5. So there's your first point, which also happens to be your y-intercept. Okay, so now let's do 1. So 1/2 to the first power is 1/2. Now we just did that. That's going to give you 2.5. Okay, so when you plug in a 1, you get a 2.5. But now let's plug in a -1. I want you to see something here. When we put 1/2 to the -1 power, you do not even need a calculator. You're just going to flip this 1/2 over. Well, if you flip a 1/2, you really get a 2. So that becomes 5 times 2, which gives you 10. So it's just the opposite of what we did in the previous problem. Okay, so now I have these 3 points, 0, 5. I'm going to go over, I'm going to do 1 and then 2.5, so go up 2 and up 1/2. But this time, -1, 10. And so again, we're going to come and connect these, and you're just going to sketch it. But this time it's going in this direction. And there's your decay. And that's how you do these.